In this video, I'll discuss the second set of principles of rotational panoramic imaging, the formation and appearance of real, double, and ghost images. You should be familiar with the general components of a panoramic X-ray machine and the key concept that by moving the X-ray source and the receptor, we create a zone of image sharpness. In moving centers of rotation and variable receptor speed, we create a curved image layer that matches the shape of the jaws. Building on those principles, I will now discuss the projection of anatomic structures to make the panoramic image. Based on the projection geometry, there's three broad categories of images that we should consider: real images, double images, and ghost images. The first distinction is between real and ghost images, and this distinction is based on the position of the object relative to the X-ray source, the rotation center, and the receptor. Objects located between the rotation center and the receptor cast real images, whereas the images of objects between the rotation center and the X-ray source are referred to as ghost images. When projecting real images, only those structures that are located within the image layer will cast sharp images, whereas the real images of structures outside that image layer will be less sharp. This graphic demonstrates the anatomic zone of structures that will be projected as real images. And again, remember that only those structures within the image layer will cast sharp images. There is a zone that lies posterior to the rotation center where the objects are intercepted by the beam twice. Images of these structures are seen on both sides of the film. Anatomic structures that cast double images include the epiglottis, the hyoid bone, the airway, and the cervical spine. Also note that due to the projection geometry, double images appear as mirror images. This graphic demonstrates the anatomic zone that casts double images. Objects that lay between the X-ray source and the rotation center cast a ghost image. Note that the ghost image is cast on the opposite side of the true anatomic location of the object. Because the object is located outside the image layer and very close to the X-ray source, ghost images are blurred and markedly magnified. When making a panoramic radiograph, the beam is angulated relative to the horizontal plane with a slightly upward inclination. This angulation causes the ghost image of a structure to be cast higher up than its real image. Interpretation of these ghost images can be tricky. For example, in this radiograph, we see a radiopacity over the right maxillary tuberosity. However, this radiopacity is a ghost image of the earring from the opposite side. Note that the ghost image is blurred and magnified, cast on the opposite side, and cast higher up relative to its real image. And when you are viewing a panoramic radiograph, remember that anatomic structures from one side cast ghost images on the opposite side, and that emphasizes the need for you to be familiar with panoramic radiologic anatomy. This graphic demonstrates the zone of anatomic structures that cast ghost images. Note that the structures are located posterior to the rotation center and that the teeth and dentoalveolar region do not produce ghost images. To be adept at panoramic radiological interpretation, you should be familiar with the zones of anatomic structures that cast real, double, and ghost images. In this graphic, those zones are superimposed over a CT scan, allowing you to visualize dynamically the structures that are located within those different zones. Modern panoramic machines provide options for different panoramic projections. Modifications to the standard projections are created by changing the path of the rotation center. As a consequence, the zones where real, double, and ghost images are produced will also vary. Be aware of this when you interpret panoramic radiographs that have been made with non-standard projections. Of note, these non-standard projections are of value in specific situations. The orthogonal projection, for example, allows us to visualize the teeth with less horizontal overlap. And as you can note with the changing zones in the shadow reduction projection, there is less superimposition of structures over the jaw. When interpreting a panoramic radiograph, it is important that you be familiar with the principles of image layer formation and the principles of image formation of real, double, and ghost images. This will allow you to accurately identify anatomic structures and to decipher the anatomic locations of shadows that you visualize.